Welcome back to the Deep Dive. Today we're looking at a technological convergence that is fundamentally changing how goods move around the planet.
Hmm.
It's that moment. The Internet of Things meets artificial intelligence. We're talking about machines that not only sense the world, but can, well, think for themselves autonomously.
It really is the operational transformation of the decade. But what's so fascinating is that the most critical applications, they aren't in those high-gloss city logistics hubs.
Right.
We're talking about the backbone of the global economy, the places everyone forgets about, the remote ports, the vast rural warehouses, the last-mile nodes where connectivity is unreliable at best.
And that brings us right to our specific focus, Edge AI.
Exactly.
It's this radical engineering shift where we move computing capabilities, the analytical brain of the system, out of the centralized cloud
Mhm.
and deploy it directly onto or right next to the devices collecting the data.
Right, on the device itself.
So our mission today is to really understand how this highly technical concept provides autonomous, resilient solutions in these hardest to reach supply chain environments.
And the challenge is just enormous. I mean, imagine a coastal port handling specialized cargo or a massive agricultural warehouse in the middle of a continent.
Mm.
These locations are vital supply chain nodes, yet they operate with limited staff, sparse infrastructure, and networks that often fail due to weather or distance. Traditional, cloud-based systems, they rely on a constant high-speed connection for every single decision.
Which means they just freeze up.
They just freeze, the internet cuts out, and the whole operation stops. That's an unacceptable failure point when you're dealing with time-sensitive logistics.
So Edge AI is like an operational parachute. It's about giving that remote warehouse its own localized instant response brain.
Yes.
Making sure that operations can continue seamlessly even if they are, completely disconnected from headquarters for a while.
It turns vulnerability into resilience.
Okay, let's unpack this. So let's start with the physical constraints these remote logistics environments are facing. When we talk about remote ports and rural warehouses, what are we fighting against beyond just, a bad Wi-Fi signal?
It's often a combination of environmental and infrastructure limitations. You might have unique challenges like extreme weather affecting satellite links or really demanding terrain that complicates physical movement and vehicle tracking.
Okay.
But the core technical constraint, it remains the dependency on high-quality bandwidth. Cloud analytics, especially for things like real-time video monitoring or complex inventory management, it just demands massive data uploads.
Mm.
If you're remote, the latency...
The delay.
Yeah, the time it takes for data to travel to the cloud and back with an instruction, it can be minutes or even hours during an outage.
And that delay is a logistics killer. It forces the whole system to just wait for remote approval. It introduces vulnerability at every single step. So edge computing isn't just about faster processing. It's about shifting the locus of control.
That's the perfect way to put it.
Can you clarify that fundamental difference between standard cloud processing and true edge computing in this context?
Absolutely. So edge computing, by definition, brings the computer processing closer to the sensors and other data sources. It moves that heavy analytical burden away from those distant cloud servers and data centers.
Okay.
So instead of sending every single byte of data across, thousands of miles to be analyzed, the analysis happens right there on the device itself or on some local gateway hardware. This means the core intelligence for decision-making is embedded right where the activity is happening.
And that fundamental shift,
Yeah.
it instantly makes the operations more autonomous, more resilient.
Exactly.
By embedding computation near the sensors, the logistics operations become fundamentally more self-sufficient. They can maintain crucial functions like sorting cargo or monitoring storage conditions, even if the main communication line is totally severed.
You're basically creating self-sufficient islands of intelligence all along the supply chain.
Okay, let's get specific about what that localized intelligence really enables. Combining Edge AI with IoT, it creates 5 critical capabilities that just redefine what's possible in remote logistics. The first is maybe the most powerful,
Yeah.
real-time analytics at the source.
This is the foundation. Every millisecond counts in logistics. Data from sensors, be it temperature, motion, or location, it's processed immediately, right where it's generated.
Right at the source.
Our sources give that great example of a smart camera in a loading bay. Traditionally, that camera streams hours of footage to the cloud for analysis. With Edge AI, the local processor identifies a misloaded container, runs the failure detection algorithm, and sends an alert in less than a second. It doesn't need to upload the video stream first.
The crucial distinction there is that the decision is made on the edge device itself. The camera doesn't just sense, it analyzes and decides. And that links directly to the second capability, reduced latency and reliance on connectivity.
Of course.
If the decision-making loop is local, the network speed becomes almost irrelevant for those moment-to-moment operations.
And that speed then empowers the third capability, autonomous operational response. We're moving beyond simple alerts here.
Right.
The system can dynamically change workflows. So if the local sensor array detects unexpected congestion at a particular loading dock, maybe a crane broke down, the Edge AI can automatically reroute the next 3 incoming containers to alternate zones. It doesn't need permission from a central planning system 5,000 miles away. That's true local autonomy.
And crucially, the fourth capability. This solves the bandwidth crisis.
Yeah.
Efficient data usage and bandwidth savings.
Huge. Since the heavy lifting is done locally, you're not streaming raw video or massive sensor logs. You're only sending, high-value summarized data or critical alerts to the central network when connectivity allows.
Think about the cost savings.
Oh, the cost implications alone are staggering. You drastically cut cloud storage fees and data transmission costs, which can be just enormous for operations relying on expensive satellite links.
And finally, number 5, we have enhanced asset management. Being able to continuously monitor the health and performance of expensive remote assets, forklifts, specialized cooling units, transport vehicles, is suddenly feasible no matter the network quality.
So your maintenance schedules can be predictive, not reactive.
Exactly.
What's fascinating here is how quickly these technical capabilities translate into just undeniable, tangible benefits for logistics managers. We're moving from reaction to prevention. That improved responsiveness decisions in milliseconds instead of minutes means faster throughput. That inherent greater resilience means operations don't just collapse during an infrastructure failure.
Let's talk about that resilience in a really high-stakes scenario. You mentioned the example of managing medical supplies or vaccines in rural regions. This isn't just about saving money anymore. It's about public health.
Absolutely. Vaccines, certain medical supplies, they need strict temperature control. In a traditional setup, if the remote warehouse loses connection, the data logger keeps recording. But central management has zero visibility until the link is restored.
Which could be hours.
Could be days. With Edge AI, the local sensors detect a storage anomaly, say a 2-degree temperature spike, and the local system immediately triggers high-priority multi-channel alerts to staff on site. It might even initiate automated secondary cooling systems if possible. The swift local response is vital, and it's completely independent of external connectivity.
And this brings up a critical benefit I wanted to touch on.
Yeah.
Enhanced security. When the data is analyzed and acted upon locally, you significantly shrink the attack surface, right?
You do.
Sensitive inventory data or proprietary operational metrics don't have to traverse public networks, sitting potentially vulnerable in the cloud.
It fundamentally changes the security profile. Instead of defending one massive cloud hub, you're securing the ruggedized local gateway and the devices themselves. That minimizes the risk of large-scale data exposure from your remote operations.
Here's where it gets really interesting. Let's move beyond the capability list and look at 3 concrete use cases from the source material. These scenarios really show Edge AI meeting the road.
Okay, so let's start with use case A, remote port container management. You should visualize a medium-sized coastal port, maybe in Southeast Asia or Northern Canada. It's operating with limited staff, handling highly diverse cargo from smaller feeder vessels. They need speed and precision.
And the traditional setup, it relies on every lift and timestamp syncing with a central transportation management system, the TMS in the cloud, for all the complex assignment logic.
Right.
So the network hiccups during a peak loading period, the cranes just sit idle. Or worse, containers get placed in the wrong queues based on old info.
Yeah.
That stoppage costs thousands per hour.
Edge AI changes that entirely. You have robust IoT sensors on the cranes, the containers, the docks tracking everything, load weight, specific contents, priority level, arrival time. The Edge AI gateway, located right there in the port admin building, aggregates and analyzes all this data locally. It's constantly running complex optimization algorithms,
It's predicting things.
predicting when a priority container will be ready for pickup, or detecting a dangerous weight distribution issue on a loading platform.
Okay, so if a sensor flags a container as, say, 3 degrees hotter than its designated temperature limit, what's the immediate local action the Edge AI takes?
The local AI immediately flags it as a priority exception. And crucially, instead of waiting for the remote TMS to even acknowledge the warning.
Which could take minutes.
Exactly. The edge system instantly alerts the nearest crew via local radio and autonomously changes the sequence plan for the yardside cranes. It directs the hot container to an immediate inspection zone or a specialized cooling bay. It prevents cargo damage and avoids that catastrophic cascade of delays that cripples traditional ports when the network fails.
That's impressive autonomy on the dock. Now let's shift gears completely to use case B, the rural warehouse for agricultural supplies. This site is probably dealing with huge variations in inventory, from perishable seeds to heavy machinery parts, and highly inconsistent demand, all with patchy internet.
The primary challenges here are environmental control and predictive inventory alignment in a low connectivity context. If you're storing specialty seeds or delicate fertilizers, humidity and temperature control are paramount.
Of course.
In the traditional system, environmental sensors might collect data, but if the local cellular network is unstable, those alerts never reach the manager until they physically check the system days later.
And that's a potential multi-million-dollar inventory loss from moisture damage or improper storage.
Exactly. With Edge AI, the local gateway constantly processes real-time data from moisture sensors, air quality monitors, inventory tags. If moisture levels exceed a safe threshold, the system doesn't wait for cloud approval. It triggers loud local alarms, sends direct push notifications to staff mobile devices, and identifies the specific aisle needing intervention.
But the AI goes beyond just alerting.
Right.
It also helps manage the actual flow of goods.
Absolutely. Based on local historical data, which is processed privately right on the Edge device, the AI can predict demand patterns for the surrounding farms. It aligns outbound truck schedules, it preloads orders based on weather forecasts and historical purchasing, optimizing the movement right there on the spot.
So the trucks are ready to go.
It ensures trucks are routed efficiently and loaded correctly before they even attempt to connect to the main network for shipment paperwork. It's predictive, local optimization that ensures the agricultural supply chain doesn't break down at the most crucial harvest moments.
And our final scenario, use case C, last mile transport node. This takes the intelligence mobile. We're talking about trucks and vehicles operating far out in rural catchment areas, often losing signal for hours at a time.
This is where the actual vehicle becomes the edge computing node. These transport trucks are fitted with ruggedized onboard AI modules. They continuously analyze real-time input from the vehicle itself, engine performance, fuel levels, tire pressure, and external data like local GPS conditions and reported traffic incidents.
So if a road closure isn't yet updated on the central mapping system, but the onboard AI detects an abnormal slowing pattern or sees local infrastructure damage via its own sensors that indicates an obstruction, what happens?
The system locally determines the best alternative route instantly. It optimizes for fuel consumption and delivery time without waiting for a cloud API confirmation. It recalculates the entire rec profile within the vehicle itself.
Why?
And what's more, if the truck is carrying temperature-sensitive cargo and the refrigeration unit begins to fail due to, say, low coolant pressure, the Edge AI can advise the driver to pull over, notify local maintenance depots immediately upon regaining signal, and even autonomously initiate a power shift to auxiliary battery packs to stabilize the payload temperature.
The Alice's decision in action.
All happen within the confines of the vehicle itself. It dramatically improves reliability in remote supply chains.
These use cases clearly show the benefits: autonomy, speed, resilience. But deploying sophisticated AI systems in remote, rugged, and sometimes unpredictable environments, that sounds like an immense undertaking. Let's address the flip side. What are the key implementation realities that need to be considered?
Deployment is definitely complex and requires thoughtful, detailed planning. You are essentially distributing mission-critical intelligence, and that requires navigating 6 major hurdles. The first is hardware and computing capacity.
Right, you can't just install a standard server rack next to a rice field or on a dusty dock. The devices have to survive extreme temperatures, dust, vibration.
All while remaining energy efficient, exactly. They must be ruggedized, and they need sufficient computing power to run complex models like object detection or predictive analysis. But that brings inherent drawbacks. Edge devices have strict constraints on memory, storage, and thermal management.
And battery life.
And for remote locations, the reliance on battery autonomy means balancing maximum processing power with the need for long operational life without constant recharging. That efficiency trade-off it's a constant battle in the field.
The second challenge seems to relate back to connectivity architectures. We established that Edge AI works when the network is down, but it can't be a completely isolated system forever.
Right. You need hybrid networks, a sophisticated blend of edge and cloud integration. Some connectivity is always required for critical tasks. Pushing new AI models, applying system updates, and synchronizing aggregated summaries with central headquarters for strategic planning. The architecture has to intelligently decide what data to hold locally and what minimal data needs to travel to the cloud. It's an ongoing data triage process.
The third technical hurdle is interoperability. If a remote warehouse has, what, 3 different brands of IoT sensors tracking temperature, motion, and asset location, how do you ensure the single Edge AI framework can interpret and synthesize all that disparate information reliably?
It's a huge technical lift. You need standardized data formats and robust middleware to integrate diverse IoT sensors from multiple vendors into a single cohesive AI decision engine. If the sensors can't talk to the AI reliably, or if the data stream requires constant transformation, the whole decentralized system just fails immediately.
Then the fourth point focuses on security, especially since you're distributing intelligence systems, which is data security and governance. You mentioned earlier that local processing enhances security, but isn't decentralization also a double-edged sword?
It can be.
If the local brain gets hacked in a remote location with minimal physical security, the entire operation is compromised instantly.
That's a highly valid concern. While we reduce exposure to public networks, we increase the need for physical security and local cyber defense. Those edge devices must have incredibly strong, tamper-proof security protocols built in. And you have to train local staff in remote regions where dedicated IT support is rare to follow best practices and report anomalies immediately. The human element of security is magnified at the edge.
And the last 2 points are about viability and sustainability, scalability and maintenance, and the all-important cost-benefit ROI.
Planning for software updates and physical maintenance in hard-to-reach locations adds massive complexity. You can't send a specialist engineer every week.
Of course not.
Systems need to be designed for remote diagnostics and over-the-air updates, even using intermittent connections. And finally, the ROI. The initial investment in rugged, specialized edge hardware and complex integration is significant. You must clearly justify that high upfront cost against the guaranteed resilience, minimized risk of inventory loss, and the potential costs you're averting by avoiding outages common with traditional cloud systems.
If we connect this to the bigger picture, looking ahead to 2025 and beyond, the connectivity landscape is rapidly improving. We're seeing massive 5G rollouts and increasingly reliable, cheaper satellite internet.
Right.
This isn't going to eliminate Edge AI. It's going to strengthen the synergy between Edge and cloud.
Absolutely. The future is hybrid. The increased bandwidth will allow for faster training model synchronization, making the local systems even smarter, faster.
What are the most exciting frontiers for remote logistics hubs in the next few years? I'm fascinated by the idea of smart digital twins.
This is truly game-changing. We're talking about creating virtual copies, digital twins of the remote ports or warehouses running locally on the edge hardware. These twins allow the system to simulate and optimize layouts, test new workflow algorithms, and predict congestion issues right there on site.
A local control tower.
It's a local control tower that runs endless what-if scenarios autonomously, optimizing every movement without reliance on a central server.
And let's not forget federated learning. This addresses that governance and privacy issue you raised earlier.
Yes, federated learning is a key trend. It allows multiple geographically dispersed edge devices to train an AI model using their local data, but instead of sending all that raw, sensitive inventory data back to a central server,
They just send the learnings.
they only send the updates to the model, the learning coefficients, to a central aggregator. This improves the overall intelligence of the network while maintaining local data privacy and efficient bandwidth usage. And finally, you can anticipate more plug-and-play edge AI modules designed for those extremely harsh off-grid power environments you see in the deepest rural areas.
This has been a truly illuminating deep dive. Edge AI is far more than just a technical upgrade for remote operations. It's a philosophical shift. It empowers devices to act decisively on information, transforming traditionally vulnerable logistics nodes into smart, resilient, and autonomous operational centers where time and connectivity are the most critical constraints.
For operators in underserved regions, this translates directly to faster throughput, greater cost control, and reliable delivery even when the internet fails. But as we stressed, the success of this shift relies on getting the balance exactly right. The appropriate rugged hardware, sophisticated hybrid connectivity, and organizational readiness to handle that level of decentralized intelligence.
The source material stated that The edge is where the intelligence meets the action. That perfectly captures why this technology matters so much to global supply chains.
It does. Now, I encourage you, the listener, to consider this. What industries beyond logistics, perhaps emergency response, remote environmental monitoring, or specialized mining operations, could benefit massively from shifting critical intelligence away from central hubs and deploying it out into the field, right where the critical action happens and reliability is non-negotiable? That's the real disruptive potential of Edge AI.